Welcome back to the Advanced Arduino Based project, and today we will learning about digital signal monitor. And here is the agenda: overview, components, principle, schematic and procedure of digital signal monitor. And this is the overview. So this system is a dynamic signal generator and monitor. So it uses the Arduino to create a digital heartbeat. Simultaneously uses the serial plotter to watch how that signal behaves. So it is a fundamental tool for understanding how digital timing affects the electrical signals. And these are the required components: Arduino Uno, capacitor, resistor, diode and oscilloscope. The digital signal monitor operates on the principle of frequency swept signal reconstruction. Here you can see the schematic and circuit diagram. So here Arduino generates a square wave by toggling pin 7. So here we connected oscilloscope to pin 7 and resistor into pin 7. So while simultaneously decreasing the delay interval to create a dynamic frequency sweep. The system then utilizes the interval ADC, means analog to digital converter, to sample the resulting voltage at pin A0, converting the physical electrical pulses into numerical data. Finally, the serial plotter performs real-time data visualization by mapping these values onto a graph, allowing it to monitor the signal stability, frequency changes and waveform patterns visually rather than just reading raw numbers. Here you can see the schematic diagram, and this is the circuit. This is oscilloscope, capacitor, resistor, diode, and next is the program. Open Tinkercad simulator, then Arduino, breadboard is not required, oscilloscope, search it here, oscilloscope, place it here, then resistor, we need 2 resistor and 2 capacitor, then we need 1 diode. So resistor 10 kilo ohm and 100 kilo ohm. So this is 10 kilo ohm and this is 100 kilo ohm, and capacitor is 100 nanofarad, and this is the diode. So I am placing it one by one. So first we need this resistor, just rotate this. So here I am connecting this terminal of the oscilloscope to pin number 7. Then this pin I am connecting to pin number 7. And this negative end of oscilloscope I am connecting to ground. Just move this. Now we need to connect capacitor. This capacitor I am connecting this to resistor and changing the color to orange, and this end of the capacitor is connected to the ground. This is ground. I am connecting this to ground and changing the color to black. Now diode and 100 kilo ohm resistor. This cathode end I am connecting to resistor, then this one and here I am changing the color to green, and this end should be connected to the ground. And I am changing this color to white. Now this end should be connected to ground again. And it should be connected to resistor end, and this should be connected to A0. So here we having A0. So yeah. Changing the color to purple. Yeah, this connection part is done. Now we need to write the code. So first part is variable declaration. So let's write vital int is a data type, interval equals to 500, then int I equals to 500, then j is 0, j is equals to 0. So that is the variable part. And next is the setup function. So here we need to consider pin number 7 as our output, and we are also using serial monitor, serial dot begin, then next is the while loop. So here we using while loop, while of I not equals to 0, then open bracket. Here we need to write the for loop for j equals to 0, then j value is less than 100, then j value is incrementing. Here close, then again open bracket, and here you need to write the digital write of 7, not of digital read of 7. So here we having one more, right? Just do it. So here we using digital write of 7, not of digital read of 7 to flip the state of pin number 7 between high and low. So by rapidly switching a digital pin, you create a square wave in this oscilloscope. That next we need to use the delay. So here we using delay microsecond of interval determines the width of each pulse. So that next we write delay microseconds of interval. remove this, close the loop, close the loop, for loop is closed. Now interval equals to I, comma, serial analog read A0, then close the bracket. So here the variable, it starts, here you can see interval equals to I. So here the variable I starts at 500, here you can see, and counts down to 0. Since interval equals to I, the delay between pulses gets shorter and shorter in every loop. So this is a frequency sweep. As delay decreases, the frequency or speed of the signal increases. So this is used to test how fast a circuit can respond to changes. And this serial.println. So this is the monitoring part. Even though we are generating a signal on pin 7, we are reading the result on pin 0, A0. So the principal analog to digital conversion. The Arduino converts the physical voltage on the pin into a digital number that the serial plotter can understand. And next I value should be decremented here. Then you need to close the while loop. Here you just write it here. Yeah, while loop closed here. Then this is the main loop. Now start simulation. So in function wide setup, here you can see the error. In function wide setup, error, hardware serial has no member. Yeah, it's here spelling mistake. Now start simulation. Values printing, but here you need to select a microsecond. Now graph also, number also showing, right? Instead of just reading a list of numbers, the serial plotter maps these values on a graph. So it allows us to see the waveform. On the plotter, you will see a line that changes shape or tightens as the frequency increases. Here you can see it's changing, right? It will providing a visual signature of the digital signal. So that's all about the digital signal monitor. For more project, please watch the upcoming videos. Thank you all.